We have a new superpower. It's directing the evolution. Directing the evolution is something that lets us create new, amazing things far beyond the limits of the theory. When you usually want to create something new, you have to know how to do it. For example, behind the creation of a skyscraper, there are the laws of statics. Behind the creation of a new chemical product, there are the laws of chemistry. And behind the creation of a new computer application, there are the underlying procedures or algorithms. Theory is essential nowadays to create new things. Theory is a sort of generalization of the phenomena. And from the general laws, we can find a solution to particular problems. With the theory, we can rationally explain each component of our system, why it's there, and how it works. But what if we don't know the theory? Well, we are in the dark forest of ignorance. And this is like the situation we are in front of a true or false examination, and we studied nothing. We are totally unprepared. So our only choice is to do some random guessing. True, false, false, true, false. Obviously, this is the opposite of a rational approach. But after all, this is our only choice. In this case, it's enough to study a little bit and apply, but there are real-world situations for which there is a real lack of theory. Situation involving very complex structures, or maybe dealing with a million or even billion of free parameters. Situations that are mysterious or only partially explained. For example, we would like to create a very complex structure constrained by demanding constraints. Or maybe we would like to synthesize a new kind of protein. But we don't know the corresponding DNA sequence that can codify this protein. Or maybe we would like to create a new form of intelligence. But we cannot train the neural network because we don't know the underlying procedures explicitly. So, what can we do? The idea is that before seeing the magic power coming from our new superpower, let's see the huge generative force of the evolution. Me, you, everyone here is here because of the generative force of the evolution. And it may be seen trivial, but from a situation of total disorder, evolution creates order. And again, maybe it's trivial, but evolution created amazing things without a theory. Without a theory. For example, sequoias are big structures, but has been created through an evolutionary process and without a theory. Also, the photosynthesis is a very complex chemical reaction and has been created without a theory. And also, forms of intelligence that are populating our world, for example, here we can see some ants, are created through continuous try and retry. And also, obviously, the intelligence of great mammals or the human brain. So, what is the secret? The secret is time plus freedom. Time, because there are no time constraints for the evolution. All the time is available. And freedom. Freedom to make it right, freedom to do mistakes, freedom to do it right, to change the rules, to override the rules, and so on. Trial and error are commonly seen as a key element in personal growth, as we have seen, and is also a key element in all entrepreneurial cultures. Also, the scientific method brings with itself a component of try and retry. So, Now, let's see how we can exploit the force of evolution. And the idea is that to create something new, we need a theory. There are situations where there is no theory, and evolution can generate amazing things without a theory. So the idea is, why don't we exploit this? And the superpower is directing the evolution. So let's now imagine that we would like to create a sort of time bubble, inside which the time go very, very fast. And seeing this world from the outside, you can see that things happen very, very fast inside it. So from our perspective, it's a very fast world. And it is also isolated, because there are no connection between the inside of the world with the outside, and very bad things could happen inside without any direct consequences on our world. And the third, there is an environment that is, an environment that is placed initially with some particular features. For example, could contain a good part and an hostile part. And maybe a basic set of rules that can partially limit the freedom of the agents. And the agents, free agents, are the second component of our system. And they are free to evolve, and could be of one type, of multiple types, or maybe also challenging each other, so they are constantly pushing up their limits. And what about the direction? The direction comes from Latin, dirigere, give a sense, give, govern. And so from how we select the features at the beginning, agents and environment, we somehow direct how they will evolve. So let's see some practical examples. First of all, generative design. Generative design is very interesting because from some user-defined calls, for example, I would like to synthesize a chair. I specify the weight, the cost, and so on. And then a computer-implemented method generates the chair. And not only one, million or even billion of opportunities of designs that all satisfy our initial goal, our initial constraints. And a very similar procedure could be applied, for example, in another completely different area. For example, to synthesize new kind of proteins. And this method is a directed evolution. And from some user-defined goals to synthesize, for example, a protein for which we don't know how to codify it because maybe it's not present in nature, carbon-silicon protein, for example, okay? We define what we want, and through million or even billion of mutagenesis, we can reach a sort of genealogic tree and select our final goal, our final result. And finally, there is a third application, for example, in the field of the artificial intelligence. Let's suppose that we would like to teach a robot to walk. We don't know how to explicitly codify the walking procedure. So what we can do, we can create a sort of simulation environment where more and more generations are trying to walk. And finally, we select the generation that is more performing in the task of walking. And we can iterate several times without a theory, without an evolutionary method. So we at Volta Robots, my company, design intelligence for small unmanned vehicles. At CES Las Vegas this year, we presented a self-driving rover that can find its way through the forest, relying only with one front-facing camera, no other sensor. So there is a form of intelligence that processes the data from the world and convert the pixels into a viable action. And this happens also on very different types of terrain. So the robot recognizes what is a trail, what is a forest trail. And this is amazing. It's possible only in the last few years. And now that we have seen this tremendous superpower of directing the evolution, let's speak about the possible implication and consequences. This means, first of all, two things. First, chaos is traditionally the enemy of a rational approach and theory formalization. But here, chaos is a developing factor. Second, not necessarily the theory comes before the creation of new things. In this case, most of the time, come after the creation of something. First we create, and then we formalize a theory, if possible. And we must expect a huge growth of this kind of evolutionary methods in the next years. In the number of application fields, in the scale, we must expect bigger and bigger environments, and with a lot of variables and the growth in complexity. And also the level of the assignment will grow. We will give to our evolutionary systems, microworlds, higher and higher level questions, and they will feedback us. The consequences are mainly two. The first one is that we absolutely need a unifying philosophy. Across the various application area that are implementing nowadays this method, because we need a unifying philosophy that keeps all the advances together. And secondly, the man is acquiring more and more a central position in the universe. And this central position is the position of the director. And this is a huge responsibility for us, because direct comes from Latin dirigere, give a direction, give a sense, govern. And we must ask us, where are we going? Is more important than giving an answer. It's more important to ask us what we want to achieve, where are we going? As you see before, all the methods start when there is a user-defined goal. New amazing things, new amazing objects, biological objects like proteins or even form of life, or even new kind of structures, design, are going to populate our world. And that's a new form of intelligence that are somehow alien. And for this reason, all these kind of objects are somehow like a dream. They are not fully consciously understood in their inner workings, but actually they work. Thank you.